I read Amazon's engineering post on timeouts, retries, backoff, and jitter, so you don't have to. Here's the simple version. The tools sound boring, but the lesson is spicy. A retry is supposed to make your system more reliable. But if every client retries at the wrong time, your recovery mechanism can become extra traffic. And if the service was already overloaded, that extra traffic can turn a small failure into a much bigger one. The post starts with the most basic distributed systems truth: failures happen. A request can fail because of the server, the network, the load balancer, the operating system, software, or even an operator mistake. So the goal is not to build a system that never fails. The goal is to stop a tiny percentage of failures from expanding into a full outage. That is where three tools show up: timeouts, retries, and backoff with jitter. A timeout is the maximum time a client is willing to wait for a request to finish. Without a timeout, a slow request can sit there holding memory, a thread, a connection, or an ephemeral port. One slow request is annoying. Many slow requests can exhaust the client or the server. So Amazon's default advice is simple: put timeouts on remote calls and often even on calls across processes on the same machine. The hard part is choosing the timeout value. Too high, and the timeout barely protects you. Too low, and normal requests get killed early, which creates retries and more load. The Amazon rule of thumb is to choose an acceptable false timeout rate, like 0.1%, then look at the matching latency percentile of the downstream service, like P99.9. But that only works if you account for the real path, including network latency, DNS, TLS handshakes, and connection setup. The best line in the post is this: retries are selfish. When a client retries, it spends more server resources to increase its own chance of success. If failures are rare and short, that trade-off is usually fine. But when the failure is caused by overload, every retry adds more load to the thing already struggling. The client thinks it is being resilient. The service experiences it as more work. Here is the scary math. Imagine a customer request goes through 5 layers of services, and each layer does 3 retries independently. If the database at the bottom starts failing under load, those retries multiply through the stack. 3 retries at one layer becomes 9 at the next, then 27, then 81, then 243 database queries. The system was trying to be reliable, but it just aimed a traffic amplifier at its weakest dependency. Backoff is the first fix. Instead of retrying immediately, the client waits between attempts. The common pattern is exponential backoff, where the wait grows after each failure. For example, wait 1 second, then 2, then 4, then 8. But exponential growth gets huge quickly, so systems usually cap the maximum wait. And once many clients hit the cap, they can all retry at the capped rate, which is still coordinated load. So backoff helps, but backoff alone is not the whole answer. Jitter is the second fix, and it is the part people skip too often. If every client backs off for the same amount of time, they all wake up together and slam the service again. Jitter adds randomness to the wait. Instead of retrying at the exact same second, clients retry across a small window of time. The total work might be the same, but the arrival rate becomes smoother, and smoother traffic is much easier for the downstream service to survive. The post makes one broader point that is easy to miss. Jitter is not just for retries. Periodic jobs can create the same problem. If every host runs cleanup once a minute, or every daily job starts right after midnight, the downstream service sees a spike. By adding consistent jitter, the same amount of work gets spread out. Amazon says this can let services handle the workload with less capacity because the peak is lower. There is another trap. Not every request is safe to retry. A read request is often naturally safe, but a request that creates something, charges something, or sends something can have a side effect. A timeout does not prove the side effect did not happen. The service may have done the work, and only the response got lost. That is why APIs with side effects need idempotency. Retrying the same logical request should not create the side effect twice. The post is also careful about retry limits. Infinite retries are obviously dangerous, but even generous retries can keep pressure high after the original problem is gone. One practical pattern is local throttling with a token bucket. Retries are allowed while tokens exist. When the bucket is empty, retries continue only at a controlled fixed rate. The important idea is not the exact data structure. The important idea is that clients need a break. So the simple version is this. Use timeouts so calls do not wait forever. Use retries for temporary or random failures, but remember that retries are selfish. Retry in one sensible place instead of every layer. Add exponential backoff so clients slow down. Add jitter so clients do not synchronize. Cap and limit retries so recovery traffic does not take over. And for anything with side effects, design the API to be idempotent. The goal is not to never fail. The goal is to fail in a way that does not recruit every client into making the outage worse. Link to the original source in the description.